Okay, we are going to finish up this factoring section today. So we have a few more that we want to look at. Okay, number 23. You might recognize this as a difference of squares pattern. It would be great if you do, but that q to the fourth power might throw you off a little bit. But if you look at 16, okay, remember your difference of cubes, a squared minus b squared factors to a plus b and a minus b. Okay, so that's a difference of squares. That's what this pattern is. Okay, so you might say, well, that is to the fourth power. I don't see that it's squared. I don't think it fits. Okay, here's a couple of things to check. Square root of 16 is 4. Okay, 16 is a perfect square. Now think about q to the fourth. If you try to square root q to the fourth, well, think about what we did with our factor tree. Q to the fourth is a q squared times a q squared. And then each of these q squareds is a q times a q. Okay, and then this is a q times a q. All right, so if I square root that q to the fourth, there's a pair of q's. Here's another pair of q's that come out. So q times q is q squared. So square root of q to the fourth is q squared. Okay, all right. So maybe that explanation confused you a little bit, but the other idea, the pattern is look at that 4. If you can divide it in half, then you can split it into two pieces that can be multiplied together. Okay, maybe that's a little easier way to think about it. All right, square root the 625. So square root of 625 is 25. You can do a factor tree and you can find that, but it is also a perfect square. Okay, since it's a perfect or a difference of squares, a plus b, a minus b. Okay, well, what multiplies together to give you that 16q to the fourth? Well, 4q squared times another 4q squared. That gives you that 16q to the fourth. Okay, what multiplies to give you the 625? Well, a 25 and a 25. One's going to be plus, the other is going to be minus. Okay, so we've just factored that, and that was a fourth degree polynomial, but we just treated it basically like it was a quadratic. Okay, now actually this one right here, this is another difference of squares. So look at your 4. Square root of 4 is 2. Look at your 25. Square root of 25 is 5. So this is going to factor some more. So we have 4q squared plus 25, and then 2q plus 5, and 2q minus 5. Okay, and there's that's completely factored now. I did not factor the 4q squared plus 25. Okay, we don't have a sum of squares, only a difference of squares. With cubes, you have a sum and a difference. Okay, number 24. All right, again, look for that common monomial. So I know I can take out a t squared. Everybody has at least a t squared and at least a 2 because everything's even. But if I look, well, 20 and 24, actually I can take out a 4. So I'm going to go 4t squared, and then let's see what's left. So 4t squared, so there's a t to the fourth minus 5t squared plus 6. Okay. Yep, I'm just double checking my exponents that I wrote that correctly. Okay, I did. All right, we have a t to the fourth, but look, it's 3 terms. Okay, so when those 3 terms show up, that's kind of your cue. Think about doing a product sum table, and let's see what happens. So multiply to get to 6, add to get the -5. So a -1 and a Nope. How about a negative 6 and a positive 1? I can't really read my writing. Okay, going to be a negative 6 and a positive 1. And that will work. Okay, so how is this going to work with our t to the 4th? Well, split it in half. So t squared times t squared, if I would FOIL that, that would take me back to that t to the 4th. And then I would have minus 6 and plus 1. Okay, this is as much as what you can factor on this one. You might see this t squared minus 6 and start thinking about difference of squares, but I can't square root the 6. Okay, that's not a perfect square, so that's all that I can do on that one. Okay. Now these are solving, but it's the same thing. We're going to start with factoring, and then once we're factored, then we can solve. Okay, however, remember, if you're going to solve, you want to have your equations equal to 0. So 26 is equal to 0, but these others are not. Okay, so let's do that first. Let's get this equal to 0. So I'm going to move the 50s to the left side. So 18s cubed minus 50s equals 0. Okay, so I can take out an s and a 2. At least I can do that. All right, so 9s squared minus 25 equals 0. Okay, well, 9s squared minus 25, this is a difference of squares again. I can square root the 9, I can square root the 25. So this is going to be a 3s plus 5 and a 3s minus 5. I am now completely factored. Okay, now find the real number solutions, or if it says solve, okay, we're going to take our factors and put them equal to 0. So 3s minus 5 equals 0 here. Now don't forget this first guy. 2s equals 0. Okay, if I divide by 2 both sides, I get s is 0. I'm sorry, I forgot my equal 0. I'm going to move my 5 over. So this is 3s equals negative 5. Well, if I divide by 3, I get a negative 5/3. And then similar over here, this time I'm going to add 5. So 3s equals 5, and s equals 5/3. Okay, so there's that one. Okay, 26. This one's already equal to 0, so that's good. You have 4 terms. Well, look at all 4 terms. Is there a common monomial that you can take out? And the answer is no. But if you kind of go back to that list we started, if you have 4 terms, put them in a box. Okay, so in a box, I'm going to have m cubed 6m squared minus 4m minus 24. Okay, numerator, m squared, negative 4. Down the first column, m. Down the second column, 6. Okay, so this factors to m plus 6 and m squared minus 4. Okay, now again, can we factor anymore? And actually, this one we cannot. It's linear. It's m to the first, so there's not going to be any more factoring with that one. But m squared minus 4, that is a difference of squares pattern. So we're going to get m plus 6 equals 0. So m is negative 6. We have m minus 2 equals 0. So m is positive 2. m plus 2 equals 0. M is negative 2. Okay, take a look. Something I want to point out. If you look at the solutions for the last problem and the solutions for this problem, notice that there's 3 solutions each, and the degree of each of these is a 3. Okay, so your highest exponent is going to tell you how many solutions you're looking for. Okay, got 2 more here. Okay, first thing, move this 60 over to the left. So n to the 4th minus 4n squared minus 60 equals 0. Okay, no common monomials. It is a trinomial though, okay? 3 terms, trinomial. Treat it like a quadratic. Do your product sum table. Product sum, negative 60, negative 4. That is going to be 10 times 6 and a negative 10. So n squared minus 10, n squared plus 6. Okay, so you're just treating it like a quadratic. It's going to act the same way. Okay, this time, if I look at these, I know it's still an n squared, but my 10 isn't a perfect square, so that's not going to factor. Okay, neither is my n squared plus 6. It's not going to factor. All right, but we're supposed to be finding all the solutions. So what you can do is go ahead and put your factor equal to 0, and look what can happen. I'm going to move my 10 over to the other side, and now you can solve using square roots. So n is plus and minus 5. Okay, so you've got, oh, not 5. Sorry. That's my fault, definitely, on that one. It's not 5. Square root of 10, I can't simplify square root of 10. Okay, so this is just going to be plus and minus square root of 10. Okay, look at this one. N squared plus 6 equals 0. Move my 6 over. N squared equals negative 6. Square root, n is plus or minus. I can't do the square root of 6. It's not a perfect square. But you also have square root of negative. So you guys remember your i's. So n plus or minus I root 6. Okay, number 28. This one, oh, I didn't put it equal to 0, but act like it's equal to 0. We're going to do factoring. So 4 terms, you're going to put your terms in a box. Okay, so 15x cubed minus 9x squared minus 5x plus 2. Okay, so factor out. So I'm going to go a 3x squared here. Well, I have a negative 5x and a 2. Well, nothing. They don't share anything. That's going to be a 1. Down this first column is a 5x. And second column, they don't share anything. It's going to be a 1. All right, so from my box, I have this. Okay, now before we go any farther, take a look at this. Okay, whatever you have as a factored version, if I multiply it back together, it's going to go back to my original. So just kind of look at this. If I do my 3x squared times 5x, that does give me that 15x cubed. Okay, so these two together does give me this 15x cubed. But right away where I see an issue, look, 1 times 1. 1 times 1 is 1, not a 2. Okay, so what's happening is your box is lying to you. All right, so you need to beware of that if I put it in a box and I factor it, you're going to get something. Your box is going to tell you something, but you do have to take a look at it, step back for a second, make sure that what your box is telling you is accurate. Okay, so I just wanted to give you one that doesn't work, just so you can see that. Okay, and I will